In a previous lesson, we were learning about square roots and cube roots. Today, we are going to learn about how to estimate what a square root of a number might be. The advice that we have for ourselves at the top of the page is to use the square roots of perfect squares to estimate the square roots of other numbers. Now, you might ask, what is a perfect square? Well, a perfect square is any number whose square root is a whole number. All right? And how do we find those perfect squares? It's quite simple. We start with our natural numbers and we square them. So 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36, etc., etc. So these numbers, 1, 4, 9, 16, 25, and 36, would be considered perfect squares. And so if we know what the square roots of these perfect squares are, then we'll be able to find other numbers. Let me show you what I mean. We have created a number line at the bottom of your page, and you should have created a similar number line in class, and hopefully you have that with you to help you work these problems out. So what do we mean by use the square roots of perfect squares to help us with other numbers? Well, this number line, we know that the square root of 9 is 3. And square root of 16 is 4, and so on. Square root of 64 is 8. Square root of 100 is 10. So this is really nice, and they're easy to do if they're finding the square root of these perfect squares. But what if, for example, I want to find the square root of 83? Well, the square root of 83 is not going to be a nice, neat whole number. It is going to be probably an irrational number. But what if I just wanted to estimate it? What if I just wanted to figure out what kind of whole number it would be close to? Well, I can start off by taking the square root of 83 and seeing where it would fit on this number line. So I'm going to drag 83 over here because I can see that the square root of 83 is greater than the square root of 81, and it is less than the square root of 100. So this 83 fits in here really nicely. In fact, it's a lot closer to the square root of 81, so I'm going to say it's going to be in that neighborhood right there. So I know that the square root of 83 is going to be somewhere between 9 and 10. And if I have to choose one, I would say it's closer to 9. So the square root of 83 is approximately equal to 9. Another way that a question could be asked is, what is the nearest whole number or the nearest integer to the square root of 83? In that case, it would be 9. All right, let's take another example. So let's remove this. Okay. Another example would be the square root of 54. So the square root of 54, I can see on the number line, would be somewhere right here. And it looks like square root of 54 would be a little bit closer to 49 than 64. So the square root of 54 is going to be in between 7 and 8, and it's going to be a little bit closer to 7. Therefore, the square root of 54 is going to be close to the whole number 7. So that is how we estimate the square roots of numbers using the roots of perfect squares. Now we can do the same thing with cube roots. I also can use the cube roots of perfect cubes to estimate the cube roots of other numbers. Now perfect cubes are going to be a lot less obvious to us because we don't necessarily use those all the time. But the same model applies. I know that if I start with my counting numbers, I know that our natural numbers, 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216, and so on and so forth. So these numbers, 1, 8, 27, 64, 125, 216, and others, are what we call perfect cubes. And we're going to use our knowledge of these numbers to help us estimate others. So once again, we've created a timeline at the bottom. Sorry, I keep saying timeline. We have created a number line at the bottom with some of our perfect cubes. The first problem we'd like to look at is the cubed root of 320. And don't forget to put the little 3 in front of the radical sign. Well, where do I think this cubed root belongs? Well, I think it looks like it fits right here between this cubed root of 216 and the cubed root of 343, which means that the cubed root of 320 is going to be somewhere between 6 and 7. And if I'm looking, it looks as though 320 is closer to 343, so I would estimate that the cubed root of 320 is closest to 7. Let's try another example. Now I have the cubed root of 100. The cubed root of 100. So where would I put the cubed root of 100? Well, it looks to me like this cubed root of 100 would belong right there. Okay, so the cubed root of 100 is going to be between 4 and 5. Okay, now which one is it closer to? Well, it looks like it's about 25 away from 5, or the cubed root of 100 is about 25 away from the cubed root of 125, and it's about 36 away from the cubed root of 64. So we can estimate that the cubed root of 100 would be closer to 5 than to 4. So that is how we estimate cubed roots and also square roots using what we know about perfect squares and perfect cubes. Please, at this time, go ahead and try the got it at the top of page 83.